with a painting. This is the Fountain of Youth from 1546, painted by Lucas Cranach the Elder, as an illustration to a very old wish to rejuvenate human beings and to stop aging, to become once more a young person. Way back in 2008, I coined the early vascular aging EVA syndrome together with my colleagues in Paris, France. And later on in 2016, this concept was picked up by the Lancet Commission on Hypertension, focused on strategies to counteract early vascular aging, to achieve a more average life course and even an ideal life course, while this is of such importance in younger age. So preventive measures should be started very early in life, maybe even before birth, to counteract this vascular aging. To the left, you see some well-known behavioral interventions to protect the vascular system and counteract vascular aging. But to the right, you see some pharmacological strategies, not only the well-known antihypertensive drugs, statins, metformin, aspirin, but also some newer drugs like rapamycin and anti-pro-inflammatory cytokine agents. There is even hope that prebiotics and probiotics could beneficially influence gut microbiota and thereby postpone vascular aging. On this slide is a list of molecular and cellular level targets for these drug interventions to stop vascular aging, addressing oxidative stress, chronic low-grade inflammation, mitochondrial dysfunction, microvascular rarefication, growth factors, mitochondrial RNA regulators, senolytics, and sirtuins. The latter ones are involved in the process of aging in general. Here I have listed 3 categories of drugs able to influence the arterial wall. First of all, we have the established drugs, antihypertensive drugs like RAS blockers, calcium antagonists, then the glucose-lowering drugs like metformin, SGLT2 inhibitors, GLP-1 receptor analogs, the modern drugs, lipid-lowering drugs, statins, ezetimibe, PCSK9 inhibitors, and more widely used in later years, the mineral receptor blockers antagonists, spironolactone or eplerenone. Upcoming drugs are anti-inflammatory drugs, polypill and sevelamer, that it could counteract the calcification of the arterial media, Munckeberg sclerosis in chronic kidney disease patients. On the horizon, we have some experimental drugs like resveratrol, resembling the beneficial components of red wine, compound 21, that is an angiotensin 2-82 receptor agonist, SIRT1 activators to increase sirtuins, calorie restriction mimetics to slow down the rate of aging, aid breakers, alagebrium, tested 20 years ago. They worked in animals, but not so well in humans. Let's go to the antiglycemic drugs. First, we have the class of SGLT2 inhibitors, and as seen here, dapagliflozin, one member of this class, is more beneficial than placebo for reduction of pulse wave velocity. It's not fully clear why this is the case, but such drugs may lower blood pressure, increase diuresis, reduce body weight, and also relax the vascular wall. Oxidative stress and inflammation are downregulated, and vascular aging is reduced. Let's go to lipid-lowering drugs. In this study, meta-analysis, different dosages of statins were compared to physical exercise. And as shown here, high dose statins, moderate dose statins were more effective, but high intensity exercise was not so far behind. But this means that also statins at higher dosages can reduce pulse wave velocity. Let's go to anti-inflammatory drugs. Canakinumab, colchicine, both have been tested, both have been published to prevent from cardiovascular complications, especially in secondary prevention. These drugs interfere with different interleukins, cytokines, and in the end, inflammatory biomarkers are reduced, thus a beneficial effect to reduce the cardiovascular risk, and thereby, I guess, also arterial stiffness and vascular changes can be improved and risk is prevented. 10 years ago, it was shown that prolonged antihypertensive treatment was able to reduce pulse wave velocity. The longer the treatment, the better the blood pressure control, the more pulse wave velocity was reduced. And there was hope that some antihypertensive drugs could do better than other drugs to achieve this. To the left on this slide, we see short-term effects on pulse wave velocity when ACE inhibitors are more favorable, but during long-term treatment, this difference to other classes of antihypertensive drugs is not so visible anymore. So I think blood pressure control in general is what matters. And one way to analyze this is also to do a systematic review, meta-analysis of all studies, including ACE inhibitors and their effects on carotid femoral pulse wave velocity. So you see, in general, they are not so much better than other drugs. It's non-significant, even if some studies show better effects. So in the end, it's blood pressure control per se that matters. The way to solve this is to combine different low-dose drugs into one quad pill, as recently published, when irbesartan, amlodipine, indapamide, bisoprolol were all added into one pill, a quad pill, with much better blood pressure control as compared to initial monotherapy, and thereby the preventive effects on the vascular tree will also be much more pronounced. We learned about the end results of the SPART study as organized by Professor Stéphane Laurent in Paris. In this study, a strategy was tested to focus on control of pulse wave velocity per se, as compared to a conventional strategy addressing risk factors in general. And the results could show no difference according to cardiovascular endpoints because lack of statistical power, but a much better control of pulse wave velocity in the red arm patients with a target of pulse wave velocity control as compared to the blue line conventional treatment. So a more focused approach will provide more benefits on pulse wave velocity and thereby prevent vascular aging, arterial stiffness. On the horizon, we have newer drugs like the senolytic drugs, the sirtuins, and resveratrol, as I mentioned previously. These are undergoing studies, especially in lab animals, but also tested in humans. For example, the SIRT1 activators increase levels of sirtuins, and thereby several beneficial changes are seen in lab animals, including a reduction of inflammation and cardioprotection that will have the potential to counteract cardiovascular disease and prolong life. I guess you know very well about the telomeres, the ends of the DNA helix that will be shortened with every cell division. However, there is an enzyme telomerase that can elongate these telomeres again. And there is also a human model, Hutchinson-Gilford-Progeria syndrome in children undergoing rapid aging from age of 10, and they die normally age of 15, 16 of cardiovascular complications and aging. This can also be tested in lab animals when manipulation of telomerase has the potential to extend the lifespan. So this is perhaps another possibility to counteract the vascular aging if such a treatment will be proven to be safe, because we also know that cancer cells are immortal and we don't want to risk cancers when we manipulate telomerase. Let's switch to longevity populations. There are a few populations of great interest, what we can learn from longevity. But let's start with animals. There is the naked mole rat living under the surface of the earth in East Africa, and they are accustomed to survive even with very low oxygen supply. They have a slower metabolism and a longer lifespan, not harmed by oxidative stress to the same amount as other animals. In Greece, there is the island of Ikaria, and one study investigated pulse wave velocity in this population in blue as compared to control populations in red in other parts of Greece. And as you can see, the pulse wave velocity was lower, especially in the elderly individuals, maybe as a reflection of a more healthy lifestyle, Mediterranean diet, the sunshine, and less stress on this island, a long-lived population. Let's go to another population in Japan, because I collaborated with some Japanese researchers to investigate differences between two districts of Japan. On the one hand, we have the Nagano prefecture in mid-Japan, well known for a healthy lifestyle, Scandinavian-like climate, and less cardiovascular disease. People from this district were investigated by use of brachial ankle pulse wave velocity and then compared with other people from the Wakayama district, not so far away, but on the coast and with higher cardiovascular risk. What was found was that pulse wave velocity was measured by brachial ankle pulse wave velocity was lower in people from the Nagano prefecture as compared to the Wakayama prefecture, especially in people aged 70 years or older. This is a sign of the healthy lifestyle and better conditions for vascular aging in people living in the Nagano district, as shown here on the slide. The nature is more Scandinavian-like, what could be of benefit, perhaps. So in summary, arterial stiffness is measured by pulse wave velocity, is the core variable associated with early vascular aging, EVA. There are different classes of drugs that can be used for the treatment of EVA. You know very well the antihypertensive drugs. Maybe the RAS blockers are more beneficial, but I guess that blood pressure control in general is what matters the most. We also have the statins, the lipid-lowering drugs, and also now the anti-diabetes drugs, especially the SGLT2 inhibitors, but also the GLP-1 receptor agonists have been shown to reduce blood pressure, and thereby they could be expected to reduce also pulse wave velocity. A strategy targeting pulse wave velocity is more beneficial for long-term pulse wave velocity control than standard care. This was shown in the SPART study. In this study, a combination of different drugs were used with the aim to control pulse wave velocity. So we need several drugs in combination. But new experimental drugs are now being tested to treat EVA, and these are under development: telomerase, active drugs, SIRT1 activators, etc. Several drugs. So we will see what that will bring. But of course, safety comes first, and all these drugs now tested in lab animals also have been tested in humans before we can trust that they are safe and able to postpone or reduce vascular aging. Thank you very much.